Hey you guys, this is module 4.4, Rational Expressions. So go ahead and take out your packet and turn to page 21, and we're going to work on problems 1 through 7. Now as you're getting that out, I'll go ahead and read the directions. It says, determine if each of the following is a proper or improper rational function. So this is going to be important because it will be on your test, even though really when we think of proper, we think that the bottom is bigger. So that means that we're going to have a horizontal asymptote at 0. And then if it's improper, that is if they're going to be the same in terms of the degrees, or if the top is bigger, then it's going to be a slant or an oblique asymptote. So looking at question number 1, we're just looking at the degrees. So what do you think? Is this going to be a proper or improper? Good. This one is improper because the top is bigger. Since the top is bigger, that means that we will have a slant asymptote. Okay, try number 2. Good. If we were to write this as a fraction, it would be over 1 and the top would be bigger. So we would say improper. Over here, question number 3. Try that. Okay, so bottom is bigger. So that means that we will have a proper fraction. So we'll have a horizontal asymptote at 0. Number 4. Top is bigger, so that's improper, and so it'll be oblique or slant asymptote. Number 5. Bottom bigger, so horizontal asymptote is going to be at 0. Okay, so questions number 6 and 7, those are the things that I want you guys to try to write down in summary of the 5 questions that we just covered. So try that on your own right now. So it says, which of the above functions have the following end behavior? So it says as x approaches infinity, it's approaching 0. And then as x is approaching negative infinity, it's approaching 0. So the question is, when is our horizontal asymptote going to be y equals 0? Because that's when the end behavior will be 0 as well. Okay, so we're looking and we see that all the ones that have a bigger denominator, so questions 3 and 5, those are going to end up having a horizontal asymptote at 0. Okay, then the last question, it says complete the statement. It says all proper fractions, which are these ones right here, will have end behavior that, so what would the end behavior be for whenever the bottom is bigger? Yeah, pretty much right here, right? So let me show you a real concise way of writing that. So as x approaches, since it's going the same direction in both ways, we could say as it goes to positive infinity and negative infinity, the function is approaching 0. See, it's real short and sweet. All right, so you guys can push that off to the side. I want you to take out a piece of paper right now, and we're going to just work on a couple problems and kind of solidify this whole horizontal, and then we're going to do a couple of improper coming up with the slant asymptote. So get some paper and meet me back about the screen in about 2 minutes. Okay, so for module 4.4, we're going to be looking at the features of rational functions. And again, on the back side of our stamp sheet, we have those 8 key things for rational functions. Make sure you guys have those memorized and dialed in, especially when as we get closer to the quiz and to the test. All right, so we talked about horizontal asymptotes. Just to recap, so all this, you don't have to memorize this. I had a short version of all of that, where if the bottom is bigger, and here's an example of whenever the bottom is bigger, the degree is bigger, then it's always going to be y equals 0. Now if they're the same, that's still going to be a horizontal asymptote, kind of like over here. The degrees are the same, but we're going to take the coefficients of the numerators. Coefficient of the numerator divided by the coefficient of the denominator. So this one would be 4 over 3. And then if the top is bigger, that's when we're going to have a slant asymptote, okay? Especially if it's by 1 degree, because then when we divide, we'll get a linear equation. Okay, so that's a slant asymptote. Remember to divide. All right, so answer this question. Put this on your paper right now, okay? What is the difference between a proper and an improper fraction? So the biggest part with this is, how can we define this? How can we just kind of nail this down so that when it comes to the test, we're not going to be fazed when we see these two words? Well, let's think about just in a numerical sense. Is 1/2, is that proper or improper? Okay, what about 3/2? Proper or improper? All right, so this one is considered a proper. This one right here is considered improper. Okay, so what do we do whenever it's like this? Yeah, this is in the camp of the improper. And the reason why is because when it comes to the definition of a proper fraction, so we could write this down. Okay, proper is when the denominator is bigger or greater than the numerator. Okay, so notice that the denominator is bigger here. Over here, the denominator is not bigger than the numerator. That's why it's considered an improper. Okay, that will be on the test. So jot that down. We'll visit it later. Now, with your shoulder partner right now, I want you guys to look at these 5 examples, and I want you to tell me if they're proper or improper. So take a couple seconds. Proper or improper? So this one here, we see that the bottom is bigger. If the bottom is bigger, then that's going to be proper. And if the bottom is bigger, we know the horizontal asymptote will be at 0. When we're looking at this one, we see that the top is bigger, so that'll be improper. And we know that it'll be a slant asymptote, so we know we have to divide to find that slant asymptote. The next one, the bottom is bigger. Well, this is a degree of 2 divided by a degree of 4. So bottom is bigger, so that's going to be proper. And whenever it's proper, it's going to be going towards 0. Okay, or the horizontal asymptote is 0, approaching 0 from either side. Over here we see that they're the same. The degree is 1 on the top and the bottom. So that is proper or improper? Good, improper. And we would just take the fraction of the coefficients, so that'll be 1/1. And this one, the top is bigger, so that means that it's improper and it's going to be a slant asymptote. We're going to be dividing. So how are you? I know you guys understand that we have to divide here, but how is your division? So that's what we want to practice next. So here we have just a real basic division problem where it's 35 divided by 5. We know that we could divide this and say that 5 goes into 35 5 times. We wouldn't have a remainder, but we would write it like this maybe. 0 divided by 5 which would just be 0, so we're really just left with 7. So now if we look at a problem like this, number 4, 5 divided by 37, 5 goes into 37 5 times, and there would be 2 as a remainder. So notice that we typically write it like this, but we could also write it like this as an addition problem. So let's practice that real quick. I've got a question like number 6. We're going to practice dividing a question like number 6. A question like number 6. Let me get out of that. So that we can practice that long division, okay, when it comes to finding that slant asymptote. So when the top is bigger and we know it's a slant asymptote, how do we find that slant equation, which is mx plus b, some form like that. So x plus 2 divided by x squared plus 5x plus 6. So from x to x squared, that we'd multiply that by x. X times x would be x squared. X times 2 would be positive 2x. And so now at this stage, we have to take the opposite of everything that we have right here. So that means minus here and also a minus here. So 5x minus 2x, we know that that will give us a 3x. And then let's bring down the 6. Now how do I get from x to 3x? That'll be a positive 3. Now 3 times x would be 3x. 3 times 2 would be a positive 6. Okay, so we see that our remainder is 0, and this would be considered our slant asymptote. Okay, so it would be y equals, and here's our slant asymptote. All right, so the bottom is bigger here. So then what would we do in this case? Do we have to divide? Is it going to be a slant asymptote? No. Okay, so since this one is proper, we know that the horizontal asymptote will be where? Good. So then what would the end behavior? Good. As x approaches positive or negative infinity, the function is approaching 0. Okay, so here we got another one where we have a cubic function up top, and then we have a function down here. Now, whenever you go a cubic divided by a linear, our quotient will be a quadratic. So we're not going to have a slant asymptote. It's not going to be a line. It's going to be a parabola, okay, which is kind of weird. So what I want you guys to do is just practice doing your synthetic division for this question, okay? Practice doing synthetic division where this is a 1, and then we've got 2, -7. We don't have an x term, so we're going to put 0, and then we have 6. So practice your synthetic right now. All right, so remember the 2 gets a free pass. 1 times 2 is 2. That'll give us just a -5. And then 1 times -5 will give us -5. This will be -5. 1 times -5 will be -5. We have a remainder of 1. Okay, so now how do we take these numbers here and put it back with like x's and stuff like that? So remember, this is our remainder, this is our constant, this is x, this is our x squared. So we'd say 2x squared minus 5x minus 5. Now what do we do with the remainder? How do we write that? Well, if we were just going to do the division, regardless of whether this is positive or negative, this is what I want you guys to do. I want you to put a plus sign always right there. Okay, and then regardless of this is plus or minus, we're going to put 1 divided by, and what we originally divided by here, which is x minus 1. Okay. All right, we're going to try a couple more. Actually, I want you guys to try this, so I'm going to give you some time. Here they go. If it's not an improper, or if it's just proper, then just write can't divide, or you could say proper. All right, so for question number 9, we see that this is going to be a proper fraction, so we're not going to divide that one. Number 10, we see that this is improper, so we can divide this. And we could use synthetic division here, so let's try to figure out what the slant asymptote is, y equals mx plus b, for this one. So if we put in a -3, that'd be 1, 2, and 5. So the 1 gets a free pass, that'll be -3, and that'll be -1, and then we'd get a +3. Now our remainder is 2, but remember that doesn't matter when we're coming up with our slant asymptote. The slant asymptote is going to be our constant and then our x term. So y equals 1x minus 1. That would be the slant. Okay, then question number 11. They're going to be the same. So we're not going to divide. This one's going to end up having a horizontal asymptote at the coefficients. So y equals 3/1. Okay. All right, let's move on here. I want you guys to take 5 minutes on that same piece of paper. I want you to list each of these 8 things, almost like as if it were a test. Put it in your own words. Ready, set, go. All right, so check your answers on the back side of your stamp sheet. And remember to revisit this, you guys. Before we take a test or a quiz, you always want to make sure that you understand how to find each of these things, because your knowledge of this is vital to your success. All right, so open up your packets, grab that, and turn to page 21 through 22. This is your classwork and homework. So what I want you guys to do for questions 8 and 9 is to find all 8 things. Okay, so list the 8 things for 8 and 9. And then for number 10 through 13, I want you guys to practice either using synthetic division or long division. Okay, and then flip the page. Let's go here. The directions for your homework are just saying to simplify each rational expression. So for this one right here, number 14, you're going to have to factor the top, factor the bottom, and then divide out. And then for a question like number 18, you're going to have to come up with an LCD, add the numerators. Just like 19, LCD, add the numerators, and simplify. Try to combine like terms. Good luck, check your answers online, and I'll see you guys next time.